So guys, welcome to our channel once again. In today's video on our WAEC Physics Exam Revision Series, we have here these 10 WAEC repeated questions to answer on the topic properties of waves. So in short, to stay till the end of this video. Let's go ahead and start with the first question here. It says, surface waves traveling in deep water at 50 meters per second are incident at shallow water boundary if the angles of incidence and refraction are 45° and 30° respectively. Calculate the speed of the waves in shallow water. So guys, in order to calculate for this, let's recall that the refractive index is equal to sine angle of incidence over sine angle of refraction. So guys, the sine angle of incidence here is 45° and the sine angle of refraction is 30°. So that will be sine 45 over sine 30, and that's equal to the speed of the wave in deep water over the speed in shallow water. So guys, the speed of the wave in deep water is 15 meters per second, and that in shallow water is not given. So we are going to calculate the speed of the wave in shallow water. So in that case, we are going to make the speed of the wave in shallow water the subject of this equation. Let's call that x. So x now is equal to 15 sine 30 over sine 45. So guys, that's 10.6, and that's option A here. So let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 2. It says, the diagram below shows waves passing through a slit S. Which wave phenomenon is illustrated by the diagram? Alright, so guys, this diagram here illustrates diffraction. So option B is the answer to this question. That's diffraction. So let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 3. It says, the amplitude of a wave is the A, separation of two adjacent particles vibrating in phase, B, maximum displacement of the wave particle from the equilibrium position, C, distance between the two successive troughs of the wave, and D, distance traveled by a wave in complete cycle of its motion. So guys, the answer to this question is option B here, maximum displacement of the wave particle from the equilibrium position. So that's option B here, guys, and that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 4. It says, which property of a wave remains constant when the wave travels from one medium into another? We have A, wavelength, B, frequency, C, velocity, D, amplitude. So guys, the answer to this question is option B here, that's the frequency. So that's it for this question. Let's go ahead and consider the next question, guys. Alright, so the next question here is question number 5. It says, the diagram below represents the profile of transverse wave. Which of the following points are in phase? Alright, so guys, here looking at this diagram, the points that are in phase here are points P and C, and also points O and S here. So guys, but the option here, out of the options, that's O and S. So let's recall that for these 2 points to be in phase, the distance between them should be equal to 2 pi. And that's it for O and S here, and P and T. So option A is the answer to this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 6. It says, when two waves are superimposed on each other, the following occurrences are possible, except we have A, dispersion, B, antinodal lines, C, nodal lines, and D, stationary waves. So guys, the answer to this question is option A, that's dispersion. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 7. So we have a diagram here, and the question says, the diagram above illustrates two waves of equal amplitudes A and frequencies approaching each other. When the two waves meet at a point 1 midway between them, the vertical displacement of the resulting wave will be, so guys, that will be 2A, because the amplitude of the two waves adding together, that will be 2A. Since the two waves here have equal amplitudes and frequency and are approaching each other here, so option C is the answer to this question. Let's go ahead and consider the next question, guys. So the next question here is question number 8. It says, light traveling through a small pinhole usually does not make a shadow with a distinct sharp edge because of A. Reflection, B. Refraction, C. Diffraction, D. Interference. So guys, the answer to this question is diffraction, and that's option C. So let's go ahead and consider the next question, guys. So the next question we have here is question number 9. It says, a wave traveling from water to glass suffers a change in its speed at a common boundary. Which of the following properties explains its observation? We have A. Diffraction, B. Dispersion, C. Interference, D. Refraction. So guys, the answer to this question is option D here, that's refraction. Let's go ahead and consider the next and last question, guys. So guys, the next and the last question we have here is question number 10. It says, sound interference is necessary to produce the phenomenon of A. Acoustic resonance, B. Doppler effect, C. Echo, D. Beats. So guys, the answer to this question is option D, that's beats. So guys, that's it for this question, and this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below, and we'll be sure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community, where we'll post major updates on WAEC examination. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.